Hi everybody, welcome back to A+ Maths. My name's Heidi Postle. Today I'd like to start by doing trigonometry. You started to learn trigonometry in Year 9, and in Year 9 you've studied right-angled triangles. As you get on in Year 10 and 11, you'll start to study non-right-angled triangles. There are 3 rules in each of these that you need to know. 2 branches, right-angled triangles and non-right-angled triangles. At the moment, they're the only 2 triangles that we're interested in. And there are 3 rules that you need to know for each. If you're in Year 9, you are only going to do the right-angled triangles. And those 3 rules are Pythagoras, which you've already learned in Year 8, Sohcahtoa, which you're about to learn. Some of you may have already heard about it, but that's what you're going to learn today. And then you have area of a triangle, which is half base times height, which you also should already know. So actually, out of the 3 rules on right-angled triangles, you already know 2 of them. So it can't be as difficult as most people make it out to be. If you've already studied in Year 9 right-angled triangles and you're now in Year 10 or 11 and you're studying non-right-angled triangles, there are 3 more rules that you need to learn. They are the sine rule, the cosine rule, and the area of a triangle, which is half AB sine C. Those are our 6 rules. 3 for right-angled triangles and 3 for non-right-angled triangles. And don't mix and match. If you have a triangle and it's got a right angle, don't even think about these rules here. These rules only apply for non-right-angled triangles. If you have a right-angled triangle, you should only be thinking about those 3 rules. If you're asked for an area, you're obviously going to use rule number 3. And if you're asked for a side length, then you have to choose if you're going to use rule number 1 or 2. And as the lesson goes on, you'll learn which one you need to choose. It's really quite easy. I've already done a video on Pythagoras' theorem, so you can look up my video on Pythagoras' theorem by Heidi Postle if you want to know how to use rule number 1. Let's move straight along to rule number 2, which is Sohcahtoa. So the whole point of trigonometry is to talk about the relationship between the sides and the relationship between the sides and the angles. And that's really what sine, cos and tan actually are. Sine, cos and tan are all the ratios of the different combinations of the sides in a right-angled triangle or in any triangle. Sine, cosine or cos, and tangent or tan is what we normally call it. Here we have sine, here we have cos, and here we have tan. If you've watched my video on right-angled triangles, you would know that the first thing you had to do with a right-angled triangle was to label all the sides with the opposite, adjacent, and hypotenuse. These are exactly the same letters as what I used in that video. So we're going to do the same thing. Here, this is the opposite, and here, this is the hypotenuse. Here, this is the adjacent, and this one is the hypotenuse, and the opposite and the adjacent. I'll abbreviate them because I don't have space. Remember that sine, cos and tan are just the ratios of the sides, depending on which angle, of course, you're starting with. And I'll explain that in a minute. Questions are always going to start with a diagram, or you will need to draw the diagram. You're going to have a right-angled triangle. Your right angle might be down the bottom left, or your triangle might be top right, or your triangle might be on the bottom right, or you might have a triangle that is upside down, where the right angle is up the top. It doesn't matter what the right angle triangle is. The first thing you need to do in any right angle triangle question is to label the sides. The hypotenuse is the easiest side to label first, and it will always be the side opposite the right angle. Always the side opposite the right angle. It will also always be the longest side. Now comes the part that's a little bit different. With trigonometry, I told you right at the beginning that you're really talking about the ratio of the sides. Well, some of you may or may not understand what I'm talking about yet, but what we're actually saying is that you need to find out which side that the question is talking about. Angles in maths are usually denoted by theta, and you say theta. And the easiest way to draw it is to just put a circle with a little line through the middle. Theta. It's a Greek letter, and usually we use theta for angles. Sometimes you might see books use alpha or beta, but usually it's theta. We can label different angles theta depending on the triangle. Theta, theta, talking about this angle over there. It's very important to first identify which angle you're actually talking about, because when we do the ratio of the sides, the ratios will actually change depending on which angle we're talking about. Let's have a look. In this example, we're talking about this angle down here. We need to identify the opposite and the adjacent sides. We've already identified the hypotenuse. We need to identify which side is adjacent to that angle and which side is opposite to that angle. In English, you know that the word opposite means opposite. If somebody's standing opposite you, they're standing over there. They're not standing right next to you. They're opposite you, they're straight ahead. If something is adjacent to you, the word adjacent in English means next to. So if somebody is adjacent to you, then they're next to you. If I tell you that two books are adjacent to each other, then those two books are next to each other. So we're going to use those words to help us figure out which side is adjacent and opposite to our angle. This is the angle that I'm talking about. Sometimes it helps to label the actual angle. The side that is opposite to that angle will not be one of those two sides. So that one must be opposite. And the side adjacent to it will be one of the sides that are part of that angle, touching the angle next to it. Of course, this side up here is the hypotenuse, so that can't be it. So it must be this side here, the adjacent. If you already understand, you could go ahead and label the other three diagrams. If not, stay with me, because by the time we finish labeling these three diagrams, you will understand how to label the triangles. Here's my angle. The side that doesn't touch any of them is the opposite side. That must be the opposite side. And the other side that touches that angle must be the adjacent side. Here's this angle. Remember, the hypotenuse is already labelled. The adjacent side is the side that touches the angle. Can't be the hypotenuse. Has to be the adjacent. And the other one has to be the opposite. Here we have this triangle. There's my angle. The hypotenuse is already labelled. The other side attached to the angle is the adjacent side. And the lucky last one must be the opposite. And hopefully that makes sense to everybody now watching. Very important that you understand this. If you didn't understand it, watch it again. Let's get back to the rule that we're trying to learn this lesson, Sohcahtoa. We know that this stands for sine, this stands for cos, and this stands for tan. Opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. Now, this is not written like this for fun. We write it like Sohcahtoa so that we can remember the order that they come in for the fractions or the ratios that we were talking about before. We need to split this up into 3. That's how the ratios are divided. And this tells us that sine an angle, because remember we're always talking about an angle, equals the opposite over the hypotenuse. Cos my angle equals adjacent over hypotenuse, and tan the angle equals opposite over adjacent. That is very important. These are the ratios that sine, cos and tan tell us. Sine, the word sine actually means the ratio of the opposite over the hypotenuse. The ratio cos actually means the ratio of the adjacent over the hypotenuse, and tan actually means the ratio of the opposite over adjacent sides. So let's have a look. I'm very aware that some of you are probably more advanced than others. So some of you may understand this a little bit better than others. That's all right. And even if you don't understand it as much, it doesn't mean that you can't do the questions. Of course, the people who understand it might be able to do the really difficult questions a little bit more easily, but everybody should be able to have a pretty good go at doing the questions, especially the normal ones that aren't too difficult. Let's have a look at a couple of examples. Here we have a right angle triangle. We know we need to label the sides first. This one is the hypotenuse. I just label it with an H. Remember that this is the angle that I'm interested in because that's the one that has the number inside. This one must be the adjacent side because it's the other side attached to the angle, and the one left over must be the opposite. I like to find out which ratio I need to find by looking at which sides I want and which sides I already know. So I want this side here, which is the opposite side, and I already know the hypotenuse is 10. So that's the side that I know and that I want to know. The sides that I'm actually interested in are O and H. Which one of Sohcahtoa has both O and H in it? Hopefully everybody agrees that that's sine. So I need to write out my rule. I have sine the angle, which is theta, 58 degrees, equals the opposite side, which is x, over the hypotenuse, which is 10. Now all I need to do now is to solve it. It's a little bit different to normal because it has a sign in it, but generally speaking, it's an equation, and we're going to solve equations the same way that we always do. If you don't know how to solve an equation, then that's a different problem. Go back and have a look at some of my videos on how to solve an equation, because that is crucial to maths, being able to solve an equation. It pops up in all the topics that you will ever do. So here, the way that I do equations is that I always try to get rid of a denominator first. So I'm going to times both sides by 10. They disappear, or they don't disappear, they cancel, and I'm left with x equals. Now, be careful here. The sine 58 is stuck together. Remember, the sine 58 is telling me the ratio of these two sides from that angle, from that perspective. So the sine 58 is stuck together. So when you want to write down 10 times sine 58, you don't need the times sign, but you should not write sine 58 times 10. The 10 should always come first. Then you get your calculator and you type it in. 10 times sine 58, close the brackets, equals, and you should get x equals 8.48, and I can write that to 2 decimal places. If for some reason you didn't get 8.48, if for some reason you did not get 8.48, but you did all the working correctly, just have a look at your calculator screen, and right at the top of your calculator you should have a little d. Make sure that your calculator has a little d and it doesn't have an R or another letter at the top. D stands for degrees, and that means that our angle here is in degrees. And there are other ways that angles can be expressed, in radians and in gradient, but you don't need to know how to do those. So it's very important that your calculator is in the right mode and that it has a little d at the top. If you notice that your calculator doesn't have the little d at the top, then you need to change the mode. And the way that you change that mode is by pressing Shift Mode, and then you get a list of things on your calculator, and you need to press 3 degrees, D-E-G. And when you press 3, the little D will appear at the top. Then do the question, and you should get it correct. Remember, the only reason you're going to need to press Shift Mode is if you didn't get the correct answer. Moving along to question number 2. First thing we need to do, always, is to label our sides. This is the hypotenuse, this is the adjacent, and this is the opposite. What do we need to do second? Circle the sides that we need or we're trying to find, and the side that we're given. So that's the side that I want to find because that's X, and this is the side that I'm given because I've been told it's 12. The opposite side, it's really got nothing to do with anything, so we just forget about it for the moment. I need A and H. Which of my rules has A and H? Hopefully, everybody spots it. Cos, cosine. So we're going to write down cos, the angle, equals adjacent over hypotenuse. The adjacent side is X, and the opposite side is 12. Simple enough. Again, we need to get rid of the fraction first. So we're going to times both sides by 12. They cancel. And I'm left with X equals 12 times cos 30. We don't need to write the time sign down. If you write it down, if you want to put down a time sign in the middle, that's okay. And then we use the calculator. 12 times cos 30 or just 12 cos 30. You do whatever you've written down. And you would get X equals 10.39 to 2 decimal places. The only reason that you would get that wrong on your calculator is if either you didn't type it in correctly or your calculator is in the wrong mode. Question number 3. Let's label our sides first. We have, be careful, this one is the hypotenuse, that's the opposite, that's the adjacent. I want to know the O, and I've been told A. Looking at my rules, O, A, there it is. I'm looking for tan. So tan my angle equals opposite over adjacent. Remember, you're not writing the O and the A, you're writing the actual values that you have on your triangle. And then we need to get rid of the denominator. Everybody should be getting used to this by now. And you write down what's left. And then you do it on the calculator. 10 times or 10 tan 40, close the brackets, equals 8.39 to 2 decimal places. So that's how to find a side. Thanks for watching. See you soon. Don't forget to share, like and subscribe.